Hey guys!
Welcome back!
Here is your second video. Today we're going to be talking about section 7.2 using the converse of the Pythagorean theorem. We've seen the word converse before. That means you just flip
it.
You flip the if and the then part of an if-then statement. So our goal is to use the converse of the Pythagorean theorem to determine if a triangle is indeed a right triangle. So the converse of the Pythagorean theorem says if c squared equals a squared plus b squared, then triangle ABC is in fact a right triangle and C is the right angle. We can tell that because capital letters, lowercase letters is the side opposite them. Little c, that's the hypotenuse. Little a, that's a leg. And little b, that is also a leg. So let's take a look at some examples.
Alright, so it says, tell whether the given triangle is a right triangle. So we want to take and figure this out, and we want to figure out which side would be my C, which side would be my A, and which side would be my B. You never just go by how it looks, because as you look at this you say, oh, this must be the right angle because it looks that way. Don't you ever do that. First you need to do, in something like this where you have a radical, just figure out a quick approximation. That's approximately 10.82. And I didn't even need a calculator to figure that out. I'm so good.
Just that smart.
It's a tough life I lead, you know? So this 10.82 is going to be my largest side, which means that has to be the hypotenuse. So I'm going to take and 3 times the square root of 13 squared equals my a squared, which you pick, it doesn't matter, either the 6 or the 9, so we'll pick this to be my a, this one to be my b, plus 9 squared. And I want to know whether those two are equal. I don't know for sure they are or not, so that's why we put the question mark there. All right, when I'm doing something like this, 3 times the square root of 13 squared. We worked a little bit with this today when we talked about simplifying radicals, but when we do this, we take the outside numbers, and we're going to multiply them together, and then we have the two numbers inside the radical that get multiplied together as well. So 6 squared gives us a 36, and 9 squared gives us an 81.
Very good.
And again, we're still keeping that question mark there because we don't know whether they're equal. All right, 3 times 3 is what, Mrs. O'Brien?
Oh, that's 9.
Ah, there we are. All right, since both these 13s are underneath the radical, we can keep them underneath the radical and multiply them together. So 13 times 13 gives me?
169.
Absolutely. So 9 times the square root of 169, and we're still curious whether that equals 36 plus 81. All right, what's the square root of 169, Mrs. O'Brien?
Well, that's 13.
Ah, yes. So 9 times 13, and I want to know if that equals, let's go ahead and take 36 and add it to 81, and we get 117 there. All right, Mrs. O'Brien, what's 9 times 13?
117.
Ah, so the question is 117 equal 117? On every single planet in the universe it does. So, based on that, Mrs. O'Brien, what does that tell us?
That tells us that the triangle we are given is a right triangle.
So I would say yes, it is a right triangle. Yay! All right, so now we're going to try this other one. So same thing, guys. Don't ever just make the assumption that this is your right angle. You always want to take a look at your side lengths. 29 is my biggest side, so that has to be my hypotenuse or my C.
And pay attention to that because you just might be given a list of 3 numbers and you always have to figure out which one is the largest. You might not be given a picture to look at.
Absolutely. So then we take these two and we plug them into the formula. Again, it doesn't matter which one you pick to be your A and a B. I'm going to pick 24 to be my A and 16 to be my B. So 24 squared plus 16 squared, and I want to know if that equals 29 squared. All right, so 24 squared is?
576.
Wow, no calculator needed. Plus 16 squared is?
256.
She needed a calculator for that one.
She's lying. I believe this one is 841.
Absolutely, 841. All right, we want to know if those two equal each other, so we're going to take and add 576 plus 256, and we get 832. And I know right away that 832 does not equal 841. So, Mrs. O'Brien, what does that tell me?
No, that triangle is not a right triangle.
Absolutely correct.
Good job answering the question asked.
Thanks. I try.
All right, so we've got two theorems that are covered in this section. Theorem 7.3. If the square of the length of the longest side of a triangle is less than the sum of the square of the lengths of the other two sides, then the triangle is an acute triangle. So if c squared is less than a squared plus b squared, where c is the longest side, then triangle ABC is acute. Theorem 7.4 says if the square of the length of the longest side is greater than the sum of the square of the lengths of the other two sides, then the triangle is obtuse. So if c squared is greater than a squared plus b squared, then the triangle is obtuse. And we already know that if c squared equals a squared plus b squared, that gives us a right triangle. So we've got three different options. If c squared is less than a squared plus b squared, it's acute. If c squared is greater than a squared plus b squared, it's obtuse. And if c squared equals a squared plus b squared, it is a right triangle.
All right, so let's give one of these a try. It says, can segments with lengths 2.8 feet, 3.2 feet, and 4.2 feet form a triangle? And if so, would the triangle be obtuse, right or obtuse? So the first part of the question that we need to answer is, can it form a triangle? We just need to know, can it form a triangle in general? So the question is, since 4.2 is our longest side, I have to make sure that the other two sides added together end up being greater than that third side.
Is that a concept from last semester?
It's crazy. It all builds on each other. Nuts, I know. So when we take and add those together, we get that 6 is greater than 4.2. That is, in fact, what we're looking for. We want those two sides to be greater than the third side. Because of that, we know, yes, it is a triangle. So now we can keep going with the rest of the question. So we want to try and figure out whether it's acute, right, or obtuse. So as we just already figured out, 4.2 is our longest side, so 4.2 has to equal our c. That has to be what we're plugging in for our c. So when we do that, we say 4.2 squared, and I'm putting a box here because I'm not really sure what it is. I don't know whether it equals, I don't know whether it's greater than, I don't know whether it's less than yet. I got to figure that out. So I'm trying to figure out what goes there, and I want to know how it compares to 2.8 squared plus 3.2 squared. Now, does it matter if I switch this 2.8 and this 3.2 around?
Not at all.
Not at all. So now we go ahead and do some simplification here. 4.2 squared is?
17.64.
Nicely done. Keep my box down there. 2.8 squared?
7.84.
Plus 3.2 squared?
10.24.
All right, then I'm just going to do some quick simplification here. 7.64, and again, I'm seeing how that compares to 7.84 plus 10.24, which gives me 18.08. So 17.84 is definitely less than 18.08. So now I'm going to go back to those theorems that Mrs. O'Brien introduced us to, and if my c squared is less than my a squared plus my b squared, then
the triangle must be acute.
Absolutely. So triangle is acute.
All right, so you are helping to install a light pole in the parking lot for work. When the pole is positioned properly, it is perpendicular to the pavement. Otherwise, we've got some weird light poles going around.
Right.
How can you check that the pole is perpendicular using a tape measure?
It's a tough problem.
Mrs. Venner, how tall are you?
Well, I'm, 5'3".
5'3".
Yeah.
Most light poles I know are a little bit bigger than that.
Yeah.
So I'm going to draw a picture. Whoop.
It's a good light pole.
We try. Here's my light pole. Here's the ground, obviously. Get some light streaming out of here. Ooh, that's supposed to be yellow.
That's green light.
Well, it's the Green Lantern.
Well, how about that?
So, if I would draw a picture, Mrs. Venner might go up to about there.
I'm yellow.
You are.
How about that?
So, she can't reach the top of the light pole, so we've got a problem.
I'm short.
She's short. So, she cannot climb her way up like a monkey and get to the top. So, that's kind of a problem, too. So, what if we used a property that we talked about last semester?
What?
I know. We're crazy. And look at some similar triangles. If she shimmied her way all the way up to the top, and we have this nice right triangle, what if we use a smaller one, maybe one that she could reach? Do you think that would help us?
I think it would.
Okay. So, since they are too difficult to measure, we're going to measure, let's say we measure 3 feet up the pole. That's something that she could reach. And make a mark. Wow. And then we measure from the ground and we measure out 4 feet. Another simple measurement that we could do. We could expect that from our mark to where we put a mark on the ground, that would have to be a right triangle. And if that works, then it would have to be perpendicular by definition of perpendicular. So if we have 3 squared plus 4 squared equals our hypotenuse squared. So 9 plus 16 gives me 25. And that's my hypotenuse squared. How do we undo a square?
I think you square root it.
Take the square root. So if I square root that, I should get 5. So if we take our tape measure and make sure that it stays super straight, get some assistance from someone else, I don't know, maybe you could take me out there.
Yeah.
If this is in fact 5, then we would have, by definition, a right triangle, which would mean that these two are perpendicular. If it's anything but 5 feet exactly, we don't have a right triangle.
So then it wouldn't be perpendicular.
So then it would be perpendicular.
And we would have light poles from Dr. Seuss's world.
We would. They kind of look like my picture.
Right.
All right.
That's okay.
So I hope you enjoyed your video. Tomorrow you are going to have a worksheet for homework, so look forward to that. Make sure you got all the notes, and we will be checking them tomorrow.
Absolutely.
All right.
Have a good night.